This is the first question. Although, I mean, this, yeah, I hope you can see the screen now. This question is not only for aldehyde ketone carboxylic acid. This is for distinction test. Here we are having reagents which are used, and this is the list of compound with functional group that is detected. Okay, so what group it can detect? So these are the different reagents, and these are the different. Here you have to look at the groups, है ना? यहाँ पे आपको groups देखना है. So for example, if the first one I will say this is an alcohol, this is an amine, this is an aldehyde, this is a phenol. It's not an alcohol, phenol. ठीक है? तो इस तरह से देखिए and tell me which reagents are used to detect these particular functional groups. This can be done, and this is covered in NCERT. This can be done. Sorry guys, I got disconnected. Uh, yeah, you can see. Take 2 more minutes for this. This could be done. आप थोड़ा सा try कीजिए, हो जाएगा, ठीक है? This could be done. Okay, Ian has answered. You guys have 20 more seconds. Okay. Please here guys. देखिए. Alkaline solution of copper sulfate and sodium citrate. एक और आंसर आया. Okay, शायद. ठीक. अच्छा. Maybe you don't know this, but let us start with let us start like this. What are the different groups? Here we are having alcohol. Here we are having amine, and this is what this is 2 degree amine. And then we have aldehyde, and then we have phenol. So at least for phenol, you should know that neutral FeCl3 is used, and it is only used for phenol and carboxylic acids. ठीक है? So B के लिए आपको क्या है? B is 4. Then you have alkaline chloroform solution. Alkaline chloroform solution, CHCl3. It is used for what? Detection of 1 degree, 2 degree, and 3 degree amines. That is why this C will be for 2. And I think your answer will be here already. B4, B4, C1, B4, C2. Yeah, C is the correct option. Okay. Also, even for the A1, what is alkaline solution of copper sulfate and sodium citrate? If you look at these two solutions, this is filling solution A and filling solution B. This is filling test. And that is why we are testing what? We are testing aldehyde with this. By the way, this is not, sorry, this is primary amine only. Na? This nitrogen is directly connected to 1 carbon and 1 degree amine. That is why it is going to give the carbyl amine test, that is alkaline chloroform solution. Try this one. Now, this question is based on tautomerism. ठीक है? तो tautomerism में क्या है? What happens in tautomerism is that if you have any ketone or even aldehydes, they can be in the keto form or they can be in the enol form. So tautomers is there in 11th standard और आप कैसे बताना है? For example, if you have C double bond O, ठीक है? So this can, एक tautomer इसका ये होगा that like this. So what is happening here? You have C double bond O. Here we have CH3. So there are 3 hydrogens here. Now, oxygen can, with its lone pair, can attack on this one hydrogen atom. And if it attacks on one hydrogen atom, it will get 3 bonds. So it will shift the bond to this carbon atom. And that is why you will see that these single bonds are as it is. This oxygen is as it is. This oxygen has got a hydrogen now. This pi bond shifted to the carbon atom. So you'll be having a double bond. So what you need to do is you need to make the tautomer for A, B, C, and D. So the most stable one, for example, this is the keto form, right? This is enol form. So you have to make the enol form for all of these and see which is the most stable enol form, and then you will get the answer. ठीक है? एक हम आपको जैसे करके बताते हैं. For example, in this case, you have to remove this hydrogen and this hydrogen. So this will be converted to alpha hydrogen निकालना होता है. आपको यहाँ पे एक डबल बॉन्ड, ठीक है, एक यहाँ पे डबल बॉन्ड, and the double bond O will be converted to OH. This will be converted to OH. And similarly, यहाँ पे आप देखिए, तो यहाँ पे आपके पास enol form जो होगा, it can be from this carbon atom and this carbon atom, or from this carbon atom and this carbon atom. So there are multiple enol forms that can be formed. उनको बना के देखिए आप. Fine. Similarly, C के लिए and D के लिए. You have to do this with your hand. What you need to do, just see the difference here. Double bond O is converted to OH, and the carbon and alpha carbon, the carbonyl carbon and alpha carbon are getting a double bond. That's the only change that is happening. ठीक है? Try कीजिए 2 minutes के लिए. Time is done. देखिए, for this you will either get something like this, OH, double bond here and double bond here, right? Or you can get an enol form, which is like this. This will be OH, this will be OH, and you will have a double bond here, and you can have a double bond here. Okay. And there is also one more thing, but in all of the cases, we'll be having two double bonds inside. No, this is interesting. Yeah, this is OH, this has OH, and this has OH. Okay, so if you see, if I'm taking this as the alpha carbon, so here will be a double bond. For this will be a double bond. And for this carbon atom, here will be the double bond. As you can see, this now what we have got is benzene ring. And that is why this C will be most stable in its enol form. And that is why, since it is an equilibrium, most of this compound will be in its enol form rather than the keto form, because the enol form it is having the aromatization, and because it is aromatic, it will be very stable. So this is the correct option. यहाँ पे अगर हम देखें, so you can have two different, you can have OH double bond, OH double bond, something like this. ठीक है? So C will be the correct option. फिर इसको copy कर लीजिए. This is stable. Due to resonance. I have copied this down. Open this. Try कीजिए थोड़ा. There is one reaction of ozone method of preparation में, ठीक है, उसी से related है. सुपर टफ नहीं है, आप थोड़ा ट्राई कीजिएगा, हो जाएगा. Take 1 minute, 1 more minute. ये देखिए. So in this reaction, what is happening? We are having oxidative ozonolysis. ठीक है. You must have ये reaction आपने देखा होगा. You have Hex2E, 6 carbon atoms, and there is a double bond here. So first step में अगर आप ओजोन डालें, and then in the second step, first step में ozone, second step में ZnH2O, and you should know that what happens here is this will cleave and you will get oxygen and oxygen here. But since we are not having zinc, we are having only water, then further oxidation takes place. And both of these fragments, they get, first of all, they get converted to aldehyde, as you can see here. 1, 2, 3, 4, double bond O. If you want to complete the tetravalency, you have to add a hydrogen here. Similarly, double bond O, and then these 2 carbon atoms, and there will be a hydrogen here. These will be further oxidized. अब aldehyde को oxidize करेंगे तो और क्या मिलेगा? You will get acids. So what are the two acids? You will have 1, 2, 3, 4 carbon atoms. So you will have butanoic acid and 1, 2 carbon atom, that is ethanoic acid. So butanoic acid and acetic acid. Okay, so these are the two products that you are going to get. If it was ZnH2, then it would have stopped at the aldehyde part. So acetic acid and butanoic acid is the answer. Please write this down. Further oxidation होगा because of O3. In place of H2O, you can also see H2O2, hydrogen peroxide, and that will also give you the same product, acids. चलिए, moving on. Pieces. You have to give the major product here. But I hope you can see the difference in the variety of questions and the level of questions also. You're having Mg and water. ठीक है. थोड़ा याद कीजिए Mg water किस reaction में use किया जाता है. Then you will get the answer. take 1 more minute. थोड़ा ट्राई कीजिए, मतलब यहाँ पे आपको नेगेटिव मार्किंग नहीं हो रही है, थोड़ा ट्राई कीजिए, लुक एट दी ऑप्शंस, एलिमिनेट दी ऑप्शंस. ठीक है, कुछ भी ट्राई किया आपने. The best thing in this case is the options are, they are going to give you a bit of hints. Okay? Options are going to give you a bit of hints. For example, the first option, if you see, this is a triangle, right? So here you are having cyclopropane, and cyclopropane, it is not particularly very stable molecule. Why it is not stable? Because all the carbon atoms, as you can see, these are sp3 hybridized, right? These three are what? sp3 hybridized. The angle, the bond angle for sp3 hybridization would be what? It should be 109.5 degrees. That is the bond angle that should be there for tetrahedral. But when you are having a triangle, even if it is an equilateral, it will be an equilateral triangle type of thing. So it will be 60 degrees only. So you can see that there is a large deviation in what angle. That is why it is not very stable molecule. It can get stability from somewhere else, but on its own, it is not very stable. And that is why 6-membered ring are not found very usually. I mean, in general, they are not formed. Sorry, why I'm saying 6. 3-membered rings are not formed. The most stable is 5-membered, 6-membered, and 7-membered rings. So these rings can be formed, and 5-member is most, and then 6, and then 7. Okay, so if you are going to form a ring, intramolecular reaction happening, and there is a ring formation, so 5-member and 6-member will be preferred. So I will eliminate this option only by the fact that this is what it is, a cyclopropane. If you look at the next case, here we are having gem diol type of situation. Here we are having OH, and there is OH on the same carbon atom. And we know that when you have on the same carbon atom, there are two OH, we call this type of situation gem diol. And in gem diol, what happens? Water should be cleaving, and you should be getting C double bond O like this. So obviously, this molecule is also not stable. It is a major product. Then you have to remove the water molecule and then write what the ketonic form. So this is not even possible. This is possible in EU. If I look at the C one, then in the C case, what you see, there is only one reaction happening. That this is the first reaction, Mg. There is no other change happening. The carbonyl group is carbonyl group. Everything is as it is. We have just added MgBr. What is happening if I add water to MgBr? There's no change. There will be some change when we add water, right? That is why this is also not right. And also one more thing, Grignard reagent is very reactive with respect to water. Grignard reagent is very reactive. We have seen that. Why is Grignard reagent prepared in the absence of water? It is prepared in the absence of water because it is highly reactive. It reacts with water and it forms what? It forms alkanes. So you can see that I can eliminate all of these options and I can write that, okay, this option will be correct because all of these are having valid reasons that these can never be a stable product, not only for this reaction, for any reaction. ठीक है, Grignard reagent कभी stable product नहीं होगा. It can be an intermediate जिससे further आप reaction कर रहे हो if there is absence of water for this reaction in particular. अच्छा, अब यहाँ देखते हैं इसमें क्या हो रहा है. If I look at the D option, then what is happening here? ठीक है, so please see. So here we have first of all the carbonyl carbon, and here we have the Br. It will react with Mg. It will form Grignard reagent. C double bond of O will be as it is, and this is as it is. Then you will have MgBr. ठीक है. Now, one thing that will happen here is there will be a reaction between this molecule. See, all the starting material that we are having, this keto-bromo type of molecule, it will not be reacting with all the Mg and forming Grignard reagent. There will be some reactant still left. So there will be an intermolecular reaction. And let us write this once again. You have double bond O, and here you have Br. Okay. Now what is going to happen? This carbon atom, it is going to attack on the keto. This is also in the method of preparation of alcohols. You make a Grignard reagent, RMGPR, you react it with aldehydes, this R is going to attack. So that type of attack is happening here. And then what is going to happen? If I'm going to, now I have to number it in order to be safe. ठीक है, ताकि when I'm going to do addition ना दोनों का, तो यहाँ पे कोई mistake ना आ जाए. तो 1 2 3 4 फोर्थ कार्बन एटम. और फिर यहाँ से स्टार्ट हो रहा है आपके पास. इसको हम लिखते हैं यहाँ पे ए बी सी डी. इसको 5 कर लीजिए आप, इसको ई कर लीजिए. सो दीज आर द 5 कार्बन एटम्स इन बोथ द केसेस. 4 और बी का यहाँ पे बॉन्ड बन रहा है. ठीक है. सो यू विल हैव 1 2 3 4 बी सी डी ई. 1 2 3 4. ठीक है. 4 कार्बन एटम्स बी सी डी ई. ठीक है. सो दिस विल बी इन वन चेन नाउ. दिस विल बी इन वन चेन. ये हम समझाना चाह रहे हैं. एक 1 2 3 4 तो 4 से अटैच्ड है. एंड देन 4 इज मेकिंग अ बॉन्ड विथ व्हाट? डी. अब बी जो है यहाँ पे आपके पास क्या हो रहा है? बी इज अटैच विथ सी डी एंड ई. ठीक है. तो इसको हमने लॉन्गेस्ट चेन जो को एक जगह रख लिया. नाउ नाउ वी आर गोइंग टू राइट इट लाइक दिस. अब देखिए यहाँ पे विल हैव 1, have 2, have 3, you have 4, 5, 6, 7 and 8. So these are the 8 carbon atoms. Now 8 carbons में एक काम करते हैं. 4 तक तो ऐसे रखते हैं, उसके बाद B C D E कर देते हैं. Then it will be easy for you guys to remember. So 4 के बाद what we are having? We are having 4 के बाद B, then we are having C, then we are having D, and then we are having E. Now let us look at the second carbon atom. Second carbon atom and ketone. Is there anything happening here? No, nothing is happening there. In the third carbon atom, there's nothing. In the fourth carbon atom, we have the fifth carbon atom. So I will write the fifth carbon atom here. Then in the B carbon atom, what is happening? In the B carbon atom, this, as it is attacking, this O negative will become, this double bond O will become O negative, and water milne pe, this will become OH. So B carbon will get a OH mole. And this B carbon also is having what? It is having a methyl group, that is A. यहाँ पे आपका A आ जाएगा. This will be A and this will be the fifth carbon atom. C में कुछ है नहीं. D में कुछ है. Yes, D में there is one methyl group and no, there's D में there is one Br group. Sorry. ठीक है. हाँ, Br group is there. And E तो आपके पास हमने यहाँ पे ऐसे लिख लिया. So this is the last product, end product that we are going to get. ठीक है. This is end product after the addition of water also. Does this make sense? Yes or no? Please tell me. So you can see it's very similar, maybe just same. जो आपका C, जो आपके यहाँ पे D में आंसर है. Please copy this down. This 1 2 3 4 5 A B C D E. This is known as mapping. मैपिंग जनरली आप लोग बोर्ड्स लेवल में नहीं पढ़ते हैं, बिकॉज बोर्ड्स लेवल में इतने बड़े मॉलिक्यूल का इस्तेमाल नहीं होता है. बट मैपिंग इज वेरी इंपॉर्टेंट इफ यू वांट टू keep a count of carbon atoms that you are having, and you don't want to increase or decrease the carbon atom. You don't want to attach something which was not attached on the carbon atom previously. जैसे सेकंड में कार्बन था तो सेकंड में ही कार्बन रहे, बहुत आसानी से हो जाता है. ठीक है. दिस इज मैपिंग. इट्स कॉल्ड मैपिंग ऑफ कार्बन एटम्स. And this is very important when you are having, if you are doing cyclization, if there is intermolecular reaction and there is a ring that is getting formed, at that time also mapping is very important. And in that case, we will just take 1 2 3 4 5. And when there is addition of two molecules, as it is happening here, there is new carbon-carbon bond formed with two large molecules. Then in that case, I generally use 1 2 3 4 5, and then I use A B C D whenever we are doing any type of addition. Actually, please copy this down. Raise your hand once you're done. Now, this type of question, although I mean it is completely based on the NCERT, but this type of question and this type of detailing is not there in NCERT. Raise your hand once you're done. Please raise your hand once you're done, guys. Tarif, Shahid, and Iyad. Just waiting for Tarif. तारीफ तो पता नहीं कभी कभी डिस्कनेक्ट हो जाती है। चलिए ठीक है, लेट अस सी द अदर क्वेश्चन। So you have to give the major product here also. See all the reagents that you can see here. SOCl2, you know, you have seen SOCl2. RNH2, you have seen. LiLH4, you have seen. Then you're just hydrolyzing it. Try this. एक 1 more minute इसमें थोड़ा ट्राई करें भाई, ट्राई करें। SOCl2 डालने से क्या होता है? In place of OH you will get Cl. Then you are adding RNH2. Once you add RNH2 to amide type of thing, then what will be happening? ठीक है सर, सोच सोच के कीजिए, हो जाएगा। इट्स नॉट वेरी टफ, बहुत ज्यादा टफ नहीं, थोड़ा समझ के कीजिए, हो जाएगा। ओके तारीफ।
So in such problems, to prove.
Okay, guys. Here what is happening? Please see. SOCl2 mean क्या होगा? OH will be replaced by Cl. You'll have something like this. The benzene ring is as it is. 1, 2, 3. Double bond O, and you will get Cl. The double bond here. Okay. After this, you are having RNS2. Now, whenever you have Cl here and you have RNS2 here, then what will happen? HCl will be replaced. यहाँ से chlorine निकलेगा, यहाँ से hydrogen निकलेगा, and you will get a molecule which is like this. So I'm writing pH, double bond, and then you have single bond, and double bond O will be as it is, and here you will be getting nitrogen will be attached here with one hydrogen and one alkyl group. One hydrogen is formed with Cl as HCl. That is also done. Then we are doing LiLH4. Lithium aluminum hydride. Now, lithium aluminum hydride, when it reacts with amide, this is not ketone, this is what? Amide. It converts amide into what? It is going to convert amide into alkene. So you'll have pH. NHR. So this will be the final product. Okay, so that is option number D. Please copy this one. याद हो अगर आपको अमाइड से अगर आपको अमीन जाना देन वी यूज LiLH4. That is why what is happening? अमाइड से अमीन. So all of these reagents they are all in CRT, but सवाल आप लोगों को थोड़ा सा डिफिकल्ट लग रहा है बिकॉज हमने बहुत ऊपर से स्टार्ट किया. Please raise your hand once you're done writing. Raise your hand once you're done. Waiting for Shahid and Iyad. Just waiting for Shahid now. Shahid, please raise your hand once you're done writing. चलिए ठीक है. Try this. A solution of the product obtained by heating 1 mole of glycine with 1 mole of chlorine in the presence of red phosphorus generates chiral carbon. A molecule with 2 chiral carbon is always optically active. Okay. So these are two statements. If you don't know the structure of glycine, let me just give you the structure of glycine. It will have 2 carbon atoms, just make NH2 over. Here we have NH2. So this is glycine. It is reacting with 1 mole of chlorine in the presence of red phosphorus. ठीक है? इसका reaction Cl2 in the presence of red phosphorus. यहाँ पे ना I will focus on the second statement. ध्यान दीजिएगा जरा. A molecule with 2 chiral carbon is always optically active. इसको अगर ध्यान से देखिए आप. Let's suppose we are having 2 chiral carbons like this. ठीक है? So this is also chiral. This is also chiral. Now this chiral carbon, it rotates the plane polarized light. Let us suppose in 50 degrees, plus 50 degrees in the right direction. The second one is also what? It is optically active. It is chiral carbon. So it is also, it will be also able to rotate the plane polarized light. But let us suppose that it is rotating the plane polarized light in minus 50 degrees Celsius, not Celsius, minus 50 degree angle, plus 50 degree and minus 50 degree angles. Now, overall, what will be the effect of this molecule? This will not be optically active because if a plane polarized light is going to pass from this particular molecule, the first carbon will rotate plus 50 degree, the second will rotate minus 50 degree, the resultant will be zero. There will be zero optical rotation, and that is why this molecule will not be now optically active. It won't be optically active. This second statement is false, and by this, only from this information, we can say that reason is false. कहाँ पे? Reason is false only in the C option. ठीक है? Now, what type of reaction happens here when we react this with chlorine? Please see. Here we are having 2 hydrogen atoms. One of the hydrogen atom is converted to chlorine. Okay, so you'll have everything as it is. You have COH. Here we have NH2, and this hydrogen atom will get a chlorine. So now you can see that this is a chiral carbon. Here we have NH2. Here we have Cl. Here we have COH, and here we have hydrogen. So this first statement is true. Please copy this down. Okay, I hope you have written this down. Try this. You have to get A and B. देखिए guys, see. So first of all KMnO4. So obviously in KMnO4 there is it is an oxidizing agent. तो यहाँ से आपको ऑक्सीडाइज होके क्या मिलेगा, कुछ ना कुछ कार्बोक्सिलिक एसिड टाइप का मिलेगा, right? Now one thing that you should understand is that ketones, they do not get oxidized easily. Okay, they do not get oxidized easily. So what will happen? You can see in all of these different forms you are having there. ये पहला ऑप्शन जो है ना, पहला ऑप्शन करेक्ट हो ही नहीं सकता. Why? Because here we are having an extra carbon atom. So how it is possible to have an extra carbon atom? I mean this carbon atom, मतलब ये कहाँ से कार्बन एटम ऊपर में आ जाए, ठीक है? So this cannot be possible. If I look at the second one, it is possible here. This is one is possible because the ketone is as it is, and the bond which is breaking between these two carbon atoms, it is getting converted to carboxylic acid. So alkene will be converted to carboxylic. That makes sense. Again, here also this does not make sense. Like how the CO2 H is coming here, because if I want CO2 H here and R here, then what bond I have to break? No, it is not possible to break any of these two bonds. Like see, they can. आपको बताते like why is that not possible? Please see. You have C double bond O, and then you are having R. So these two bonds are impossible to break. These two bonds. Why are these two bonds impossible to break? Because there are two enol forms that will be situated. You will have enol form which will be looking something like this. Double bond R and OH. Similarly, there will be a enol form which will be looking something like this. That is R here as it is, OH here, and there will be a double bond here. So since both of these red bonded or the white red bonds, they are having partial double bond characters, so it is very difficult to break them. The most easiest one to break will be this carbon atom, this bond. I will write this in green. Why it is easiest to break? Because if I'm going to break this one, then I will get a positive charge here, and this positive charge, what it's going to happen, it will be very much stabilized because it is what 2 degree. Okay. Now let us see. Obviously, this is now this is going to break, and once this breaks, then you will have R C C double bond O, right? And then what else will be having? There will be this carbon atom which will be getting COH. Okay, this carbon atom will be getting COH. So now there are two valid options in this case. That is the option number B, which is having C double bond O as it is, and this one carbon atom is getting converted to COH. Similarly, B option, here also we are having the C double bond O as it is, and there is COOH. Okay. Acha. Now, if you see what is happening in the next reaction, there is NH2 and KOH. So this is what this is Wolff-Kishner. Wolff-Kishner reduction, what does it do? C double bond O को ये किस में convert कर देता है? CH2. Any aldehyde or any ketone, it will be converted to alkane. So in the B case, let us see what is happening. C double bond O is getting converted to alkene. And because we are having KOH, so KOH डालने से क्या होगा ना? Carboxylic acid will be ionized and it will be in carboxylate ion. And in order to reconvert it to carboxylic acid, we are just using H3O positive. Okay, we are having an acidic condition so that it is reconverted to COO negative, is reconverted to COOH. Okay, there is no other use for H3O positive here. So what's going to happen now? This is getting converted to CH2, and here the COOH is as it is. So this is correct. The problem here that you can see is the COH is also getting converted to CH3, which is not possible unless we have a very strong reducing agent. So B option will be correct. Okay. So first step में क्या है? This is oxidation. And the second step is reduction. Stop this down. Moving on. Try this. KMnO4 को वैसे आपने देखना है. What does KMnO4 alkaline KMnO4 does to different alkyl groups? It's not very tough. Alkaline KMnO4 क्या करता है? If you heat an alkaline KMnO4, ये जितने भी alkyl groups है ना, all alkyl groups are converted to all alkyl will be converted to COH, carboxylic acid. ये भी convert हो जाएगा carboxylic acid में. Here if you see this whole thing will be converted to carboxylic acid. This will be also converted to carboxylic acid. ठीक है? So this ये पूरा चीज निकल जाएगा. And here you will have COH. ठीक? If you remember, there is one reaction now. If you have R and KMnO4 and heat, what will happen? You will get benzoic acid. ये NCERT में ही है reaction. Just a second, let me show you. Method of preparation of carboxylic acid. What they are saying? They are saying aromatic carboxylic acid can be prepared by vigorous oxidation of alkyl benzene with chromic acid or acidic or alkaline potassium permanganate, KMnO4. The entire side chain is oxidized to carboxyl group, irrespective of the length of the side chain. Primary and secondary alkyl groups are oxidized in this manner, while tertiary group is not affected. Sif tertiary is not affected. Suitably substituted alkenes are also oxidized to carboxylic acid. So, as you can see, this is what completely like alkenes का भी यहाँ पे reference है. ठीक है? Suitably substituted alkenes are also oxidized to carboxylic acid. That means all of these groups will be converted to carboxylic acid, and the option A will be correct. So their basis is already in NCERT, लेकिन obviously the exact सवाल नहीं. Okay, that is it's important to like read NCERT now. Moving on, let's see one more question. reduce the sizes. चलिए please see. प्लीज ट्राई कीजिएगा इसको भी, है ना, ऐसे बस बैठे मत रहिए। लिथियम, यू हैव लिथियम बोरोहाइड्रेट, ठीक है, LiBH4 है, AlH4 नहीं है। Hey guys, we have lithium borohydride. So lithium borohydride, it is used for the reduction of only esters, selective reduction of esters. If it was sodium borohydride, तब तो कुछ नहीं होता. If it was lithium aluminum hydride, then both CO2 and CO2H and CO2ET, both of them would have been converted to alcohol. But here we are having lithium borohydride. It is used for the selective reduction of esters to alcohol. So only this group is going to get reduced to what? OH. ठीक है, यहाँ पे जो कार्बन है कार्बन तो रहेगा, the other COH हो जाएगा मतलब ये, ठीक है, whatever else is present that will be converted to OH. So you have 1 2 3 4 COOH and 1 2 3, and this carbon atom will get the OH. Okay, so the option number D is correct. You can write lithium borohydride is used for selective reduction of esters.